Hi everyone, we're the McMaster Exoskeleton team, a student engineering team from McMaster University competing in the ACE competition, where teams design and build functional lower limb exoskeleton systems. For this year's build, we're upgrading our actuator architecture, and these motors are a key part of that. Today we're unboxing the CubeMars AK70-9 KV60 V3 actuator, and we'll walk through a few things. What kind of motor this is, why it's widely used in exoskeletons, the dual encoder feedback system, the included cables and interfaces, and finally, our initial testing setup. Right away, you can see the AK79 comes as a fully integrated actuator module, not just a bare brushless DC motor. Inside this compact unit is a full BLDC motor, a 9-to-1 planetary gearbox, and an integrated driver. This level of integration really simplifies both the mechanical and electrical design, especially for wearable robotics like exoskeletons. In the box, we get a CAN communication cable, a power cable, and mounting hardware. To interface with the motor, we also use a USB to serial cable for configuration, an external power supply, and lastly, fuse and protection wiring for testing. All of these parts are linked in the description. Now, you are probably wondering why we chose this motor. The AK79 is optimized for torque and controllability rather than extremely high speed, which is exactly what human assist systems need. This type of actuator is commonly used in robotic legs, wearable exoskeletons, and assistive robotics. We chose it because of its high torque-to-weight ratio, compact and lightweight design, integrated motor driver, CAN communication support, and dual encoder feedback. For wearable systems, weight is critical since the device is worn by a pilot. The AK79 delivers strong torque output in a very small form factor. This makes it ideal for hip and knee assistance. The dual encoder also provides additional feedback to our control and AI systems, improving motion accuracy and responsiveness. Now let's go through the cables. The power cable supplies DC voltage to the integrated driver. The CAN cable is how we communicate with the motor from our main controller. We use CAN because it is robust, noise-resistant, and ideal for multi-node systems like our exoskeleton, where multiple joints communicate on the same bus. The USB to serial cable is used for initial setup and configuration using the CubeMars upper computer software. Here are some clips from our initial testing setup. We power the motor using a regulated DC supply and communicate over CAN through the configuration software. Right now, we're testing position control, torque control, current response, encoder readings, and communication reliability. Before integrating into the full suit, we verify current limits, mechanical hard stops, and software fault protections to ensure safe operation. And that's our video with the CubeMars AK79 V3 actuator. We're excited to integrate these into our next exoskeleton build and continue improving performance and reliability. If you want to follow our journey to ACE, make sure to subscribe and follow the McMaster Exoskeleton team. Thanks for watching.